Today, we're going to pull back the curtain on a system that honestly, quietly governs the quality of pretty much every physical product you buy. It's a statistical tool that allows global trade to even function, and it does it by answering one simple but incredibly complex question. What's good enough?
Okay, let's just dive right in with a scenario. Put yourself in the driver's seat. You're a business owner. A massive shipping container with 10,000 units of your brand new product. It has just arrived. The excitement is real, but so is the pressure. So now you've got to make a huge decision. How in the world do you make sure the quality is what you paid for before you ship these things out to your customers?
And this brings us to a fundamental challenge in manufacturing. We can call it the quality control dilemma. You're basically caught between two extremes, and frankly, neither one is a great option.
Okay, so on one hand, you could inspect every single one of those 10,000 items. Sure, that guarantees you catch every defect, but the cost would be astronomical. It's incredibly time-consuming, and for some products, testing is actually destructive. Think about lighting a match to see if it works. Then on the other hand, you could just check nothing at all. I mean, it's fast, it's cheap, but the risk? It's massive. You could be sending out tons of faulty products, completely wrecking your reputation, and facing some serious financial losses. So yeah, neither extreme is a practical way to run a business. What you really need is a smarter approach, a middle ground that balances the cost with the risk, using statistics to make an objective call on the entire batch without having to physically check every single item.
And this is exactly where a strategy called acceptance sampling comes in. It's a way to judge an entire production run based on a small, representative sample. And this whole method is built around one core concept, AQL.
So, AQL stands for Acceptance Quality Limit. It's an industry standard that sets a really clear, pre-agreed-upon limit for defects. It's essentially the line in the sand. If the number of defects you find in your sample is below this limit, you accept the entire order. If it's above, you reject it. It's that simple. I think this official definition from the ISO standard is just fascinating. It frames AQL not as some target for perfection, but as the worst tolerable quality level. It's a really practical way of admitting that, hey, in mass manufacturing, some defects are going to happen. AQL is really just about defining how many is too many. But hold on. Before we can even count defects, we have to agree on what a defect actually is. Because in the world of quality control, not all imperfections are created equal. They're usually sorted into three distinct categories. First up, we have critical defects. These are the worst of the worst, the absolute deal breakers. A critical defect is something that could actually harm a user, or it violates regulations. Think of a sharp edge on a baby toy, or faulty wiring in electronics. For these, the tolerance is zero. The AQL is always 0%. One critical defect and the whole batch can be rejected.
Next up are major defects. Now, these aren't dangerous, but they're issues that would probably cause a customer to return the product or think it's unacceptable. It might be a product that just doesn't work, a really noticeable visual flaw, something like that. A very common AQL for major defects is 2.5%.
And finally, we have minor defects. This is usually a small thing that, honestly, most users wouldn't even notice or care about. Maybe a slight color variation or a tiny imperfection in the finish. A typical AQL for minor defects is set a bit higher, somewhere around 4%. Okay, so let's get to the practical part and see how this all builds into a clear, actionable tool. All of these concepts come together in something called the ASQL tables, which are the industry standard for making that final accept or reject decision. Before you can even look at a chart, you need to know three things. First, your lot size. For our example, that's 10,000 units. Second, your inspection level, which basically determines how many samples you'll check. Level 2 is the most common, so we'll stick with that. And third, your AQL limits, which we just talked about. Let's stick with 2.5% for major and 4.0% for minor. Okay, here's the first table. We find our lot size, which, at 10,000, is between 3,201 and 10,000 pieces. Then we look across to our chosen inspection level, which is level 2. And where they meet, that gives us a code letter. In our case, that letter is L. Simple as that. This letter is our key to the next step. All right, this is where it all comes together. We find our code letter, L, on the left. The table immediately tells us our sample size is 200 units. Then, we look across to our AQL columns. For our AQL of 2.5%, the limit is 10. For our AQL of 4.0%, the limit is 14. So this means we accept the entire 10,000 unit order if we find 10 or fewer major defects and 14 or fewer minor defects in our 200 unit sample. But if we find 11 major defects or 15 minor defects, we reject the whole lot.
So you might be thinking, that's a lot of tables and numbers. Why does this all matter so much? Why has this one statistical method become the absolute backbone of global supply chains?
Well, the power of AQL is that it transforms quality from a subjective feeling into an objective, measurable standard. It creates a common language, so a buyer in New York and a factory manager in Vietnam can both understand and agree on exactly what's expected. It provides that crucial balance between the cost of inspection and the risk of poor quality. It just removes emotion and argument from the whole equation, giving you a clear, data-driven yes or no on an entire order. And ultimately, it's a system that builds trust.
At the end of the day, AQL is a pragmatic solution for an imperfect world. It acknowledges that demanding 100% perfection from every single production run is often financially impossible. Instead, it provides a smart, efficient, and globally accepted framework for managing risk and just making sure the products we receive meet a standard we all agree on.
And really, AQL forces all of us to think about a fascinating question, not just as businesses, but as consumers too. In a world of mass-produced goods, what level of imperfection is truly good enough? AQL provides a statistical answer to what's almost a philosophical question, and it's a trade-off that is baked into nearly every single product you own. Kind of makes you think, doesn't it?